Hello, everybody. Welcome to this webinar today on number properties, where I'm going to use the topic of prime numbers to teach you some very important skills that you are going to use throughout in your quant preparation. I promise this is going to be a very fruitful 90 minutes. Just be very open to learning, and you're going to have a good time. Here's the goal of the session. I want to demonstrate how you should apply concepts in a unified approach, how your approach should not just change from one question to the next every time. You should not really be trying to figure out on the spot, okay, this new question, what do I do? Now, this is a new question, what do I do? Every question should not be a new battle. You should have a unified way of approaching questions so that you feel confident with whatever question the exam may throw at you. Here's the flow of the session. Understand this very, very carefully. We are all going to start with a small warm up session where we will do 4 simple questions. The goal will just be to warm ourselves up and get into the groove, get some conceptual questions running, and recall some concepts. So, 500 to 600 level if we go to GMAT terminology. So, through these questions, as I said, concept revision will happen. And then, after I teach you these concepts, it'll be time that you test yourself for the first time. This will be a small practice quiz, sprint 1, with 3 questions, and the level is higher than the warm up. This is 600 to 700 level questions. And then we will increase the bar one more time as we go to sprint 2, which is where you're going to do 2 questions, 700 plus level. So the hardest level. So as you can see, we're steadily increasing difficulty. It's a progressively difficult session so that you continuously grow your ability and get ready for the next stage. And throughout the session, you're going to get feedback and a lot of takeaways that, okay, this is a mistake I made. What does this indicate? What kind of a mistake am I making? What is my gap? And all of those things. So be ready for all of this. I welcome all of you one more time. I'll just take this opportunity before we start to introduce myself. I am the lead quant SME at e-GMAT, Shweta, and I have been here in the past with another session. Probability permutation combination is another session we had, and you guys received it really well. And today also, just be very open to learning, and you're going to have a lot of fun. With this, let's get right into the warm-up section. Here are the instructions for you. We will have 4 questions, as I already told you. Now, no answers to those questions should come in the chat here, because if you do that, you influence somebody else who's trying to attempt the questions. And we don't want that. We want everybody to have a fair attempt. So there will be a poll. You click on the link, and that's where you give your answer and then come back to the session. Okay. And each question, right after you do it, we will discuss it. So let's have the first poll here, please. I am also going to show the question on screen right after the poll comes. Let's have the poll. It'll be in the comments, and that's where your poll is. This is the first question. All the best. Okay, we have the accuracy here. 76% of you guys got this question correct, which is very good. The most popular incorrect answer choice was A. And now before I move on, there were a lot of comments here where you guys put your final answers. Maybe you joined late and you didn't hear what I said at the top. Do not put your answers in the chat. We have polls for a reason so that everybody gets a fair chance at doing the question. Now, since 76% people anyway got this correct, we do not need to go into a very detailed discussion here. We're just going to do this quickly. So, we wanted to find out which statements are true here out of these. Now, first statement really depends on the definition, what a prime number even is. So, a prime number, as you know, is a positive integer that has exactly two positive factors, one and itself. And when you have more than two positive factors, that's when you start calling it a composite number. So here are some examples of composite numbers. Now, when you look at the number one, how many factors does it have? The number one has only one factor, which is 1 itself. So it's not two exactly factors which can make it prime. It's not more than two prime factors which can make it what? More than two factors which can make it composite. That's why 1 is neither prime nor composite. And this is now the list of the first few prime numbers, consecutive prime numbers. There are, of course, infinite more as you go on. Now, when you just use all of this information, you can see that 2 is even. The others are all odd, yes, but this means there is also an even prime number. In fact, this is the only even prime number. Every other prime number is odd. But this alone is enough to reject the first statement. The first statement said that prime numbers are always odd. So that's wrong. Second statement also is automatically wrong based on what we discussed, that one is neither prime nor composite. Third statement talks about consecutive numbers that can never be prime. So look here, these two numbers, 2 and 3, these are consecutive numbers. 2 and 3 come right after each other, right? One after the other. And both of them are prime. So two consecutive numbers can be prime. 2 and 3 are your examples. But very important here, it's the only two consecutive numbers that are prime. Just look at the word only here. There is no other pair of two consecutive numbers that can both be prime. So every time from here on, there will be a gap. So you can see 3 to 5, there's a difference of 2, 5 to 7, difference of 2, 7 to 11, difference is 4, and so on. The difference is never again going to be 1. And that's it. Using all of these pieces, we can say that out of these three statements that we had in this question, none is true. Okay, all of them can be false. Good. With this, let's move on to question number 2. We're always going to be fast when accuracy is good, because this session has to be tailor made for all of the people who are here right now. I hope 24% of us who got this wrong are now clear. Most popular incorrect choice, which was C, meant that you people thought the third statement is true, which means you missed out on 2 and 3, this pair of consecutive integers. But be careful next time on. Let's have the next poll, please. And then we'll see question number 2. This is your question. Good luck. All right, then we have the accuracy data. 62% of the class voted for choice C, which is the correct answer. So, this accuracy is lower than what we had for the previous question, that was at 76%. And this time, most popular incorrect choice is B. Let's see what happened here. So, how do we find prime factors of a number? This is actually pretty basic, where prime factors come from prime factorization. So the concept is that every time that you have a positive integer, k, what's a positive integer? 1, 2, 3, 4, all of these are positive integers. Every time you have one, you can always express it in this form, where p1, p2, p3, all of these are prime numbers, and m, n, r, these are just some non-negative integers. These are the powers of your prime numbers. Really, now non-negative means zero and positive, but if something has just a power of zero, then we don't really need to write that in the prime factored form. So m and r are positive every time you have an integer other than 1, because if you try to express 1 like this using prime numbers, you will not be able to. I mean, you want to write 1 is equal to 2 to the power something, that has to be 2 to the power 0, otherwise it's going to have 2's. So other than 1, whenever you're writing the prime factored form, it has to be a positive power. And what this really means is that this number k has this prime factor p1 m times, or these many p1s it has. So when you look at this example, say I look at 4, which is 2 squared. So 4 has 2 2's, and 8, which is 2 cubed, that means 8 has 3 2's. That's the number of prime factors. 6 has 1 2 and 1 3. 12 has 2 2's and 1 3, and so on. So these are the prime factors that these numbers have. Now, with this logic, if I use this on 4004, I do the prime factorization here, you will see that it has a 2. It has two twos, yes, but whenever you're talking about the prime factors that a number has, you will always take the distinct prime factors that it has, unless your question clarifies, it specifies that you will use all prime factors even if they repeat. So if it specifies that, then you use the repeated ones also. Otherwise, just take the distinct prime factors. So you're going to have 2, 7, 11, 13, which is 4 prime factors, and that's it. That makes C the correct answer. So Julia says, I'm dumb, I put 5. That's precisely what I said. This is a very common mistake where we take all of the prime factors that it has, even if they're not distinct. But this is a learning. That's okay if this time you made a mistake. But from now on, look out for that word where they say not necessarily distinct. Otherwise, only give them distinct prime factors. Okay. Let's have the next poll, please. Question number 3. Everybody be careful. Again, all 4 questions will be like this, where we'll try to set some conceptual foundations before we really get to application. All right, warm up. Question number 3, poll is here, and this is your question. Good luck. All right, accuracy is lower now as I expected. It's 50% this time. So half the class got this and half did not. Popular incorrect options are A, C, D. That means we were very confused about what the correct answer should be. We had some interesting discussion going on here. Surodeep liked the question. Kunal says this one took some effort. It will take effort as we steadily go on. Um, Abhi says none, that's not right. Then he says two only, that's also not right. Okay, could be true. This question is could be true, that is the trick. Okay, let's see if that really is the trick. One is also true. All right, good. So you people were really engaged with the question, which is very good. And that's why the communication here is also thoroughly about the question, which is good. Let's see now. So through this question again, my goal is to build a concept in you in case you're rusted to bring that concept back. So again, bringing back my prime factored form of a number. So k is equal to this, where p1, p2, p3 are the prime factors of k and m and r are the powers. Now think about it. If you look at these three statements that I have, there are two things that I have done to number n. One thing that I've done is I've multiplied something to it. So it has become 3n or 5 times or 7 times. Second thing that I've done is I've raised it to a power. Not in the first statement, but in the second one, it's n squared and it's n to the power 7. So I really need to understand what happens when these two operations are done. What happens when you multiply something to a number and what happens when you raise it to a certain power. So here the first thing I'm trying to show you is what happens if you raise a number k to a certain power a. So you will notice how each of the prime factors they stay here, but the powers just get multiplied by a. This is basic exponent laws. So it's the same prime factors. You see, k to the power a has the same prime factors as k. Simple example, if k is 2, k squared is 2 squared. The prime factor does not change. If k is this thing here, even after you do k to the power 5, the prime factors stay the same. So however many prime factors k has, k to the power a will also have the same. Similarly, let's think about the second thing, which is when you multiply a constant. Now, what happens here? So, see, this whole thing is your k, and here is an extra thing that you're multiplying. It's not something that just settles itself in the power like in the other case. This is something extra that you're multiplying. Now, very important. P1, P2, P3, I know all of these are prime factors, but what's A? This a may be a new prime number. It may be a prime factor that k did not already have. In that case, when you add this k to the picture, it will be an additional prime factor, right? It will be one more. But it's also possible that this a here is anyway one of p1, p2, p3, in which case this ak will have the same prime factors as k. So this is very important. I'll show you an example. So in this one, if k is 2, even 2k is 2 squared. That means this extra that I multiplied, this 2, this was already a prime factor of k. So it didn't really do anything. But if I have k as this thing, which has 2, 3, and 5, and then I multiply a 7 to it, I am giving it a new prime factor, which will increase the number by 1. So that's why the statement that AK, the product, may or may not have the same prime factors. Are we all clear about the concept? Please come in the chat and tell me, is this concept clear? I still have not talked about the three statements here, but if you understand the concept, then the three statements will really be very, very easy. Are we clear about this? Okay, yes. Good. So let's see now, based on whatever we have. This first statement, which is 3n, is just the product case, the AK case. Now, AK may or may not have the same, right? So if n has two prime factors, it's possible that 3n also has two prime factors. It's also possible that 3n has how many prime factors? Tell me what's the other possibility that exists for 3n. Let's see who gets that first. What's the other possibility for number of prime factors of 3n? While you do that, I'm going to talk about the second statement as well. I'm sorry. So n has two prime factors. N squared is also going to have two prime factors. Okay, Sarthak, Julio, Durgesh, Rahul, very well. Everybody got this correct. That's the other possibility, that you get one extra. Well done. Second statement then, n squared still has two. The 5, when you give it, it may still have 2, but it can also go to 3. And that's why this is true. Same story here. The second statement now. The third statement, what's the problem? Can someone tell me? Good, everybody gave correct answers here. Sanchari, Sarthak, Sandeep. Tell me what would be the correct answer for statement 3. We know this is wrong, but what's right? Try to correct the statement. Sanchari says, if k is multiplied by a composite number, then will it change? Good question, Sanchari. But again, say you multiply by 6, and the prime factors then that you're giving are 2 and 3. If both of them are already a part of k, then again, it won't change. So it's the same logic, whether it's one prime factor you're giving or 2 or 3 or whatever, it just is already there or it's not already there. Extra thing here is, if I'm doing 6, it may increase my number of prime factors by 2 because of 2 and 3 both not being already a part. I hope that helps. uh okay, what does it say? 2 or 3, says Sarthak. That's correct, absolutely correct. Everybody who said 2 or 3, you guys are correct. Well done. With this, then, we are going to warm up question 4. Let's have the poll. Keep the energy going, and you're going to have lots of fun when we really get to the application stage. Warm up seems very promising. Poll number 4, please. Yes, here's your poll, and here's the question on the screen. All the best. All right, accuracy data here. Accuracy is at 52%. The correct answer is choice E. Most popular incorrect answer was A. Let's see. So, through this question again, my goal is to build another concept in you, which is about how to find total number of factors, total number of odd factors, and even factors of a number. So, let's just dive right in. Again, we will come back to our prime factored form of the number k. In fact, every time you talk about prime factors or factors, this is the first thing you should do. This is how you should translate all of that English into math and really start seeing the factors that we're talking about. So, in our case, whenever you write down a number like this in its prime factored form, the total number of factors will be given by this formula. Julio says, I manually found all factors, then I counted even and odd factors. Curious if prime factorization is a faster method. It's way faster. Let me prove that to you and tell me how you like the method once I give it to you. So, first formula I've already given. This is the total number of factors. All you're doing is you're increasing each power by 1 and then you're multiplying those numbers. So this becomes m plus 1, n plus 1, r plus 1. You just multiply all of that. So when you really see that happening in 900, this is the prime factored form. So total number of factors is just increase each power by 1. That's going to be 3, 3, 3. Multiply them and 27. Okay, you already face red, droopy eyes. Wow. Are you actually typing that or you meant to send an emoji? That is too much. Yes, Surodeep. If somebody actually tries to list all of those factors, it is too much. But just look how easy life is when we have something like this. Now, again, this is total number of factors. We still are not done. We need to see how to get the total number of even and odd factors. So, very interesting. Listen. You tell me before I show something to you. 900 is a number that has a lot of factors. It has even factors also, say 2 or 4. It has odd factors also, like 3 or 9. How will I ensure that every factor I get is odd? What prime number should I not use at all in those factors? Let's see who understands my question even. If I want to create an odd factor, which prime factor of 900 will not be a part of that factor? Okay, yes, 2. 2 is the prime factor that we will not use. So, if we will not use it only, just think of the rest of it that you have. You have 3 squared and 5 squared, and just see all of the factors that this thing will have. Again, formula remains the same. Increase the powers by 1. So, 2 plus 1 for this one and 2 plus 1 for this one. 9 is your answer. And that's it. No counting. Another question to all of you. If I have total number of factors also, I have odd factors also, how am I going to get number of even factors? Do I need a third formula or do I already have everything? Let's see who gets this. You raise 3 to the power 3 instead of 2. Oh, that's just a typo. I did the correct thing. Yes, subtract both Rahul and Sarthak. Good. So, since I know total number of factors and I also know the odd factors, even factors are just going to be the rest of them. So, 27 minus 9, 18. And now, when I just read my three statements, I can see that all three of them are true and I am done. That's it. No formula available. No formula needed only. Anushka says we need a third formula. Now, do you understand we never needed a third formula? And tell me, how did you guys feel after all of these four warm up questions? How did you like this exercise? Which concepts had you forgotten? What's your biggest takeaway till here? Yeah, subtraction. Everybody gets that now. Amit, Kavish, good. Yeah, biggest takeaways from the warm up. How did we feel? How comfortable were we? Before we move to the sprint. Easier than my method, absolutely. Harshil asks the question, will even factors be more than odd factors where 2 is a prime factor? That's a good question. See, even factors is not all of the factors. When you're taking even factors, you're really just taking the rest of it. So mm, it's actually a very interesting question. We have to understand that odd factors are equal to half of the total or less than half of the total. I really can't create a rule with that, so I would not say generalize it like that. Veronica says that was awesome. Thank you. Durgesh says it's a really nice question. Surodeep is waiting for the main questions. Yes, we are going to get there. But without this warm up, I assure you the sprint would not have been as comfortable. Now, at least I'll be able to talk about these questions and say, okay, why did you make this mistake? You already knew the concepts. So, biggest takeaway for Veronica is how to get total factors. Yes, that is a formula that once you have, it makes this kind of a question really fast. And also how to get odd factors, total number of odd factors, right? Okay, I think Julio agrees. So, before we move to the exercise that everybody is waiting for, let me tell you about some more sessions that we are bringing for you. This is one session you're in today, and this journey that we are on with you is not going to end. We have another session March 25 where it's not just verbal quant, but it's the whole of your preparation. You need to define your personalized study plan so that you guarantee you are on the surest path to success. See, all of you might want to get to the same destination, a Q50 or a Q51 if I talk about quant, but you probably have very different starting points today. Some of you may be at a Q30 or a 35 or a 40. You will have very different paths, and that's what you need to understand here. So attend this session. Just click on the link that you see here and you will be able to register. And then the very next day, Sunday, will be another session on number properties. Today, here also, we are here for number properties, but today the focus is on prime numbers. And this session that you see on Sunday that Harsha is going to conduct, this will be on divisibility and remainders, which is another very important concept in number properties. I'm sure you don't want to miss this. I know how good these sessions are and how much they teach. Just click on the link and register. Okay, Durgesh says how to remember all of this. I've done these concepts, but in time crunch, it doesn't click. Durgesh, it's revision that you always will need. If you've done a concept a while back and you don't just look at it at all, then the concepts have not really stuck with you. So revise, maybe write these things on a piece of paper and stick it wherever you study so that you can see coming and going whenever there's a formula, especially. And yes, you have to constantly keep revising. And when you are thorough with it, when you can say my foundation is set properly, then you will not struggle when you see questions. These will come naturally. Harshal says, biggest takeaway for me is coming to know about these formulas which existed, but I never knew since school days. School doesn't really teach you these because they want you to derive more than, just give you a formula. The goal there is different. Here also, we hate giving you formulas, but the reason I'm giving this to you is that the core behind this formula is in permutation combination, and I can't talk about that here. But at e-GMAT, we don't ever give you a formula straight off. We explain the why behind it so it stays with you. That's another reason, Durgesh, that it doesn't stay with you because you don't know the why behind them. So that's something that the course will help you change. Now, about the personalized study plan that I was talking about, the session I already talked about, that's an overall strategy session. But here you can get your study plan, something that looks like this picture that you see on the phone. You can see your journey, you're starting to your target. Just click on this link here that you see for booking a call. Again, these are limited slots and you will get them on first come first serve basis. So whoever registers first will get a slot. You have the link in the chat. With this, we are back to quant. So we're going to start the sprint that everybody was talking about. So quick instructions again. There are going to be 3 questions. No answers in the chat, please. Put your answers in the poll. We discuss each question right after you're done. Let's have the link for the first question, please. Sprint 1, question 1. I'm going to show it right now. Here you go. Trust yourself, this might look crazy, but it's nothing you don't know. Good luck. All right, accuracy is here. 63% of the class got this correct. Popular incorrect choices were all of the other choices. So there was confusion. And I could see how Surodeep said it's a beautiful question. And if you can visualize it, it's really easy. It is indeed. Ankit says, I couldn't have solved it without warm up. Well, that was the purpose of the warm up, to give you the concepts first so that that is out of the way. And after that, it's just applying things properly, methodically. Sarthak also liked the question. Julio realized the mistake where he went wrong. Good. That's what it means to have a good foundation, really, to understand what's happening. So let's discuss this, since 47% of the class, 37% of the class got this wrong. So let's see. How many prime factors does square root of q have? Okay, so I need prime factors of square root of q. Now, you know something from before, that if you have a number k, then its power, k to the power a, will also have the same prime factors as k. Now, in this, only thing that's needed is that both of these numbers should be integers. So, k is also an integer so that you can do the prime factorization, and k to the power a is also an integer so that you can do it. So, in this case also, q to the power half is what square root of q is, right? This will have the same prime factors as q itself, provided both of them are integers. Now, q is already an integer that is given in the question. What's given? That q is the square of an odd integer. So, if it's the square of an integer, it is an integer. Now, think about whether square root of q will be an integer. So say q is the square of n. It's the square of an odd integer, right? So q is n squared. What's square root of q then? Square root of q is n, and n is the integer you started with in the first place. So these two really are integers, and therefore prime factors that you want ultimately of square root of q, that's the same as prime factors of q. So that's the first thing we understood, that they are asking square root of q, but we don't have to worry. We are just going to give it the prime factors of q. So level 1 accomplished. Julio says, my thought was, if q had 4, then square root q has 4 too. Oh, why? Square root of q in that case could just have a 2, right? Moreover, it's square of an odd positive integer. It can't have a 4. Coming back here. So next piece of information in the question was, 8 times q to the power 8 has 4 prime factors. Now, 8 is 2 to the power 3. Why am I rewriting? So that I can see this whole thing in terms of prime factors, right? That's what we're talking about. Now you again know that power of a number and the number itself, k to the power a and k, have the same prime factors if they're both integers. So q to the power 8 will have the same prime factors as q. That's why I'm just replacing it. Similarly, 2 to the power 3 has the same prime factors as 2. So I ultimately get to this stage that 2q has 4 prime factors. Now, what about q from here on? See, n is odd and q is the square of n. So q is also odd. If q is odd, 2 is not already a factor of q. And that's why when you multiplied 2 with q here, when you did 2q, you really did give it a new prime factor that it did not already have. That means there were some prime factors of q, and then a 2 came with it, and that's when it became 4 prime factors. So how many did q have then? Q had 3, and that's it. That is your final answer. Did everybody understand this question? Just look at the entire flow. If I did not have this odd piece of information, then this 2q had 4 prime factors. There could be two possibilities. One, that q already has a 2 in it, in which case q would also have 4 prime factors. The other is what we saw, that q does not have a 2 in it, and that q had 3 to begin with, and 2 was a new prime factor. Nitesh says, explain by taking an example. Example of what, Nitesh? I directly used the concepts we had done. Example of what part specifically? Everybody else, tell me how did you understand? If odd was not mentioned, then what? So if odd was not mentioned, as I just said, then Q could have 3 or 4 prime factors. So you would not be able to exactly tell how many prime factors this had. And yes, answer would have been A in that case, Harshal. Good that you're thinking that way. What if it was not there? By taking any odd number, you can do that, Nitesh. Just take anything. Take n equal to 3 and take q equal to not n equal to 3, because your final answer has to match that q has 3 prime factors. So maybe take q equal to 3 times 5 times 7, 105. That's an exercise for you, Nitesh. Take 105 and do this entire exercise. You'll be able to see why everything here holds true. Okay. He wants q to be replaced with a number. Yeah, but that's not how it's going to work. If it's already a number, you can just count how many prime factors it has. No, why would we make all of these inferences? We will just prime factor the number and get the prime factors that it has. Here it has to be inferences, the way I showed you, using the concepts that we built. Okay. So Nitesh, if you're a little unclear about this, of course, this video is going to stay on YouTube. You can take your time, look at it again. If you're uncomfortable, comment, and I will come back and respond for sure. Okay. For now, let's have question number 2, everyone. Let's have the poll, please. Question number 2. Okay, you understood. Great. Question 2 is also going to be something about powers. So keep this concept that you saw applied for the first time. Keep this in mind. Your first time accuracy was not bad, by the way. It's going to get better. Here's question number 2. Good luck. All right, pretty good accuracy this time. 73% of you got this correct, which is good here. Previous question was, I think, around 67. So good that this is going up. Now here you have a positive integer which has three prime factors. So I know I can write it like this immediately, taking P1, P2, P3 as the three prime factors, and it has eight total factors. Now, how do we get number of factors? We know that we just take the powers of our prime numbers, increase them by 1, multiply all of that, and so on. So this product is equal to 8. So really, it's a product of three numbers which has to be equal to 8. So you should think, how can I write three numbers that multiply to 8? There's only one way. There's 2 times 2 times 2. If you're wondering why not 8 times 1 times 1, well, if any of these is 1, say b plus 1 is 1, then it would mean b is equal to 0. Then that would mean p2 is not even a prime factor, but that's wrong. All three of these, p1, p2, p3, they have to be prime factors, so the powers have to be positive integers. Okay, so that way there's only one way that I can express 8 as a product of three numbers, and from here I can get the values of a, b, c. Done. Now, question is, how many factors does x to the power n have? Well, once I have the prime factored form of x, getting x to the power n is straightforward. Your powers just get multiplied by n. And now you want number of factors. You just use the same formula again. Increase each power by 1. Multiply all of that. And you have n plus 1 to the power 3, which is choice D. That's it. This was a definition. Yes, straight on. But the new thing in this question was to use number of prime factors and number of total factors to get the exact prime factored form. That is, to get the exact powers. That's what you did here in this question that we didn't do before. Ali says how to use the poll. Ali, just click on the poll link. It will come every time we go to a question. Just check this out for the next question. There is going to be a poll for question number 3. Just click on it and you'll be able to mark your answer right there. Let's have the next poll. Okay, here's your poll. Sprint 1, question 3. Good luck. All right, 65% accuracy, popular incorrect choices B and D. Okay, let's see. So 65, not bad, but again, it's very close to the accuracy we've had for these questions. This is medium to hard level, 600 to 700, and the accuracy kind of proves that. So Sarthak says it took some time to get a hang of this one. Again, it's I hope you really did get a hang ultimately and you could do it the right way. As long as that happened, it's okay if you took time right now. The goal when you're first learning application is not to be really fast, it's to really nail application so well that next time something like that happens, you're more natural with it. So here, when we see the question, k is a positive integer, k is a factor of x, which is a positive integer, and x has 8 factors. Now you again know how we get factors. It's the product of what? The powers increased by 1. So in our case, if my number x is this, then the number of factors is going to be given by this. So in our case also, x has 8 factors. That means 8 is the product that we are looking for. Now in the previous question you had a short thing that it's 3 prime factors, so you were very sure that you have to express 8 as a product of 3 numbers. This time you don't know how many factors it has, how many prime factors x has. So all of these are okay. You can express this as a product of 3 numbers, which will mean that x had 3 prime factors, or as 2 numbers, as you see in the other two, which will mean that x has 2 prime factors. Very important that you understand this. And in each case, in the first one, 8 times 1, it's really just one prime factor, because you know when 1 gets multiplied, it means the original prime factor had 0 as a power. That's what increases to 1. That means it wasn't even there. So you see from here that x can have 3 possibilities. X can have 3 prime factors, 2 prime factors, or 1 prime factor, right? This is thing number 1. Now, my question is about k squared times x to the power n. I know powers are not going to do anything, so at least this will have the same prime factors as kx. Just taking away the 2, which is the power of k, and n, which is the power of x. Once you have kx, you know it's something that you've multiplied to x. Now, this may or may not have the same prime factors as x. It depends on what? It depends on k. But you know k is already a factor. See, the unknown that there was, that, okay, I don't know if it's adding anything new or if it's, already a part. This time you know it's already a part. It's already a factor. So k is not going to add anything new. Therefore, kx will have the same prime factors as x. So overall, this k squared x to the power n, whatever they were asking, it's actually as simple as just saying, give me how many factors, how many prime factors x has. And as you just saw, it has 3 or 2 or 1, and therefore the answer is E. Tell me whether you people understood this. And if you have any questions, just ask right now. This was a very good question. The simplification involved here was intense. It really simplified the mess into something really, really simple. Having k squared x to the power n and having just x on the other side, the contrast is pretty stark. If only you know how to make these inferences and how to simplify your way to getting questions correct. So, did we understand this? If you're clear, just write on C for clear in the chat. If you have any questions, ask that right now. This is the last question of the first sprint. These were 600 to 700 level. Next, we are going to go to 700 plus level. So you really need to get everything clear till here. Let's see. C if you're clear. Okay, we have C here. And if there's a question, feel free to ask. I'm going to summarize quickly the takeaways that we have. What if it was given that k is prime? It doesn't matter whether it was prime or not. The idea is whether this prime or whatever number k is, whether it's already a part of x or not. Even if it's a prime number, it could already have been a prime factor of x, right? And it could not have been also. If instead of saying it is a factor, it said a prime factor, even then it would stay the same way. Okay. All right. Now, takeaways from here. What all did I teach you? First, k to the power a, same prime factors as k if they're both integers. Second, the product k and a may or may not have the same prime factors as k, because this a may add something, may not add something. And third thing, prime factors and factors, they're not the same thing. Prime factors are the building blocks. They are what make up a number, and every factor is also made up of prime factors. So this definition should be very clear in your head. So I'll quickly tell you about the sessions that are upcoming. So March 27, you have a strategy session that Rajat is going to host, where he will help you define your personal GMAT study plan so that you're on the surest path to success. Next day, Sunday, March 26, will be a webinar on number properties. Today is also number properties, but this is prime numbers. And this Sunday session is going to be divisibility remainders. Very, very important topic. So make sure you register for these on the links that you see in the chat. And this is now an opportunity for you to interact with one of our strategy experts. We will be able to help you generate your personalized study plan. You will know your starting point, your target, how long you're going to take, what you should do, everything. Click on the link, book a call, limited slots, so the slots may run out very soon. Okay, with this, I am ready to take you all into sprint 2. For now, before we do that, tell me, what are your biggest takeaways from sprint 1? What were your biggest learnings that you're excited to take forward, that you didn't know of? Let's summarize everything till here. When we pause and reflect, there's high chances that we take that forward and don't just forget it right there. Okay, let's have some interaction here. Sprint 2, by the way, is going to have 2 questions, just 2 hard questions, 700 plus level. And it's going to really require everything that you know right now. I think I'm experiencing an earthquake here in Delhi. Okay, how is everybody? What are your biggest takeaways? Let's have the poll for the first question, please, in sprint 2. All right, here's your question. Good luck.
Hello everyone. So I'm Ashish here. I'm also a part of the e-GMAT Quant expert team. Shweta had to leave her house and this webinar because of the earthquake situation. I shall take over the session from here. Sorry for the delay that we had to go through, but I think a lot of you felt the tremors that were going around with the earthquake. I am here in Kolkata. I didn't feel it at all. Um, so I suppose this was happening in the northern regions of the country. So we shall start from where Shweta left. We were in this question of Sprint 1, Quant 1, question 1. Yeah. Uh, so this is the question we had. Um, and I guess with the learning that we got from Sprint 1, this question was pretty easy. So we shall go to the solution here. The question asked how many prime factors does square root q have? So we were not given any more information in the question stem. We shall go and look into the statements. Statement 1 tells us that q to the power 8 has 3 prime factors. Now, in the concepts of the warm-up and in the sprint 1, Shweta made us clear that we know when the prime factors of k will always be equal to the prime factors of k to the power a, right? So if we know the prime factors of q to the power 8, we know the prime factors of q, and thus we would know that we would know the prime factors of square root q. Is that it? No, but um, we do not know whether square root q is an integer or not. So for example, 2 and 4 have the same prime factors, right? 2 has the same prime factors as 4, but does square root 2 has the same factors as 2? No. So we do not know here whether q is a perfect square or not. So statement 1 here is insufficient because of the information. It's very important to know that whether q is a perfect square or not, or whether square root q is an integer or not. Next, statement 2, we have q is the square of an odd positive integer. So here we get to know that q is a perfect square, right? And prime factors of q would be equal to the prime factors of square root of q. We know this now. But do we know the prime factors of q? No, statement 2 does not say us anything. Statement 1 had told us the number of prime factors of q. Statement 2 just says that yes, if q is like, it tells us q is a square, perfect square, so square root q would have the same number of prime factors as q. But we do not know the number here. Now, when we combine both the statements, so statement 1 tells us that q has 8 prime factors, as 3 prime factors, I'm sorry, and square root q has the same prime factors as q. This is told to us in statement 2. So when we combine both of these information, when we combine them, we get to know that square root q would have 3 prime factors. We get a definite number of prime factors. So we can surely say that both the statements combined give us the number of prime factors that square root q have. Therefore, the answer to this question was C. I hope everyone gets this. So if it's clear, this is my first time taking a webinar. I hope I have been able to explain this question. If everyone gets this, please comment a C. It would mean a lot to me. And then I guess Shweta is back here. And for the final question, Shweta would take over. But it would be a really good feedback for me going forward if you guys can comment C. Great, Sarthak said C. Okay, I'm happy that I could explain the. Thank you, Kunal. Thank you so much. So I hope everyone is safe. I haven't had the time to go through the news yet, but I hope the earthquake situation was not too bad. Shweta is here. I don't know whether she'd be able to take the. Okay, yeah, she will be able to take. So the final part of the we are left with just one question. Stay here with us. Finish this webinar. The final question is also a 700 level question, it would be a fantastic question. So I will now request Shweta to take over. We'll
Thank you so much, Ashish. Thank you. It was pretty intense here. So everybody rushed out. It was my whole computer, everything was shaking. So everything looks to be okay now. Tremors were felt in Delhi. Let's have the poll for question number 2, please. And let's get going. I'm gonna. Ashish, I think you're sharing the screen. So if you could just stop sharing and bring my stream back. And if you've already done that, then good. Poll for question number 2. Okay, poll is here, everyone. All the very best. Here you go. All right, very low accuracy this time, 31%. Now, I don't know how many of you saw the YouTube video that I had put before this session where we had announced this session. This is the challenge question that I had showed everywhere, and this is the level that you ultimately should aim to get to. Now, let's see why 69% of the class got this wrong. Kunal says this one was a curveball. Yeah, let's try to now navigate all of those curves and understand what happened here. So, again, all of you need to be very interactive, talk throughout this entire discussion, ask questions. This is your chance to really get to that next level. Okay, so let's understand what the question first is giving us and asking. K is a positive integer greater than 1. So 2, 3, 4, 5, whatever, anything it can be. How many prime factors does 14K have? Which concept does comes to your mind when you look at 14K and K together? Just give me some keywords so that I understand you're thinking about the right concept. I'm just going to take the first correct answer that comes in the chat and I'm going to move on from there. Which concept comes to your mind when you look at K being given and 14K being asked? And what is it that we should really start thinking about? This is where I'm kind of testing you within the test. How much has everybody been listening? Okay, there's a slight lag between when I say things and when they come there, so there's always this little delay in the comments. Okay, prime factors of K include 7 and 2 or not? Sarthak, that's perfect. You are really trying to see what this 14 is doing to K. So it's all about understanding the 2 and the 7 that 14 already has. What about these numbers along with K? Wonderful. Kunal got this. Factors of 14 may or may not be factors of K. And this may or may not, this yes or no, this is something that creates cases for us. There's a yes, there's a no. So here are these three cases possible. First, both 2 and 7 are factors of K. Second, only one of them is a factor. It's either 2 or 7. And third case is that both of them, none of them is a factor. Okay, now I get it. You get it already that we created the cases. Okay, so that means this is where you were stuck. Now, when I think about each of these cases one by one, look at the first one. If 2 and 7 both are already a part of K, the 14K doesn't have anything other than K, right? So, number of prime factors of 14K is the same as number of prime factors of K. In this case, it's just about finding K somehow. Second case, if one of them, 2 and 7, is already a prime factor of K, but the other is not. So the other one will still be a new addition, right? So number of prime factors of 14K is going to be one more because of that extra addition than prime factors of K. And in the third case, it's going to be two more because 2 and 7 are both new. I think Sanchari had asked a question, what if it's a composite number that we multiply? If Sanchari is still here, 14 is a composite number that we multiplied, and see how different possibilities exist. Now, we have to find out overall prime factors of K and somehow understand which case is applicable here, because the answer is changing every time. Now, statement 1, when I see K to the power 4 is divisible by 100. What is 100? It's 2 squared times 5 squared. So K to the power 4 has 2 and 5 as prime factors. That's it. If K to the power 4 has it, then K also has it, right? So K has 2 and 5 as prime factors. Now, does this clearly tell you which case you are in out of the three cases we wrote? Well, 5 I didn't even want to find out about. We've just found something out. But for 2 at least I found something. But do I know about 7 even now? I don't know 7. It may or may not have 7. So I still don't have that clarity that which case am I in. Now, Other than 2 and 5, I have no idea what other prime factors k has. It might have 20 other prime factors. I have no idea. So statement 1 is not sufficient. Ashish, can you tell me the percentage that went with A and D? So everybody who would have marked choice A or choice D would have thought that statement 1 is sufficient alone. And all of you therefore would have made a mistake on this statement in whatever we have seen till now. One common mistake that people make is they assume that K only has 2 and 5. And in that case, they feel okay, it has 2, it does not have 7, so it's the middle case that is written. So see, 10 and 5, 15% of the class went with A or D. So all 15% of you, this was your mistake. Make sure you don't repeat this. So every time you understand a mistake that you tend to make a note of it and be very careful next time on. Second statement is 50K has two prime factors. So it's a product. Okay. Now 50 already has two prime factors, no? It has 2 and 5. If 50K also has two prime factors, then what did K do? K did nothing else. K did not add anything new. That means K has nothing other than 2 and 5. It can have 2 and 5 or one of them or none of them, but nothing else. Okay. So it may have a 2, it may have a 5, or it may have both of them. It can't be one because it's written that it's greater than 1. So I can't say it doesn't have any of those prime factors. Now again, because of these multiple cases, statement 2 is not sufficient. Ashish, how many people, what percentage for B? Again, the people who marked D, they made a mistake with the second statement also because they thought the second statement is also sufficient. Again, common mistake here is K has no prime factor other than 2 and 5, just assuming K is 1, missing the constraint in the question, or just taking that it has 2 and 5 both. 40% of the class marked B. That means all of you thought this statement was sufficient. Now, this really calls for some interaction. No? Everybody who marked choice B, give me your reasoning and tell me the step that you faltered at. While you do that, I'm going to help us all tie these things together. Statement 1 gave you that K has 2 and 5. Statement 2 says it has nothing other than 2 and 5. Together, these two things guaranteed that K only has 2 and 5 both. There is no 7. That guarantees you're in the middle case here that we saw, and therefore you get the number of prime factors as 1 plus those for K. So C is the correct answer. The accuracy here was, I forgot, 31%. See now, 31% and 40% for B. There are more people with B than there are with the correct answer. Sarthak says, I assumed K has both 2 and 5, did not take into account it can have either and not both. So, talking about second statement. See, that's what I said. That's a common mistake. When we say that K has nothing other than 2 and 5, that doesn't mean K has to have 2 and 5. So, see how I talked to myself. Yes, I'm explaining things to you, but my habit is when I'm solving questions like this, I talk to myself like this, that it has nothing other than these two guys. That means it can have these two. So that assumption doesn't directly jump at me. It's like, think logically how to progress from one step to the next. I think many other people would have made the exact same mistake. Okay, summarize more, guys. Again, what mistakes did we make? I'm gonna meanwhile bring us all to the takeaways that we have from sprint 2. Thoroughly analyze each piece of information in a question. Everything matters. There was this one question we had, n is odd, and then somebody asked, I didn't understand why odd was given, and then somebody else explained very nicely why odd was given. So that's the value of every piece of information in a question. It matters. Now use your concepts to infer everything you can. When you had that question with k squared and x to the power n, concepts helped you get ultimately till just x. Without concepts and those inferences, the question was complicated. Overall, if you're less stressed, you're more confident, and if you are confident, you're going to be more accurate. I strongly believe that if you are confident, 60% of your battle is won, not even 50. It's from experience. I have seen what panic does. It affects your mind so much. There was this instance where I could not even remember the value of square root of 2. I was doubting myself. Is it 1.414? Is it 1.14? Is it what? That happens when you're under stress. Trust yourself. Trust that you've prepared and you're ready to take on everything that there is. So, again, session on March 25. Define your personalized plan, your journey by clicking on the link, register for the session, and the next day we'll be back with Quant Number Properties. Harsha is going to conduct this session, which will move around divisibility and remainders mainly. This is another link in the chat to get your personalized study plan. Let's have the links, please. They've said three things. The links haven't come yet. They'll be coming soon. Book a call to get your personalized study plan. And now I talked a lot about the right way to solve questions, how to attack everything slowly, translate all of that English into math, how to be careful if there's a constraint in the question that okay, it said it's odd, so you have to take odd, you can't take even. Then consider all the cases that there are. What happened in the last question just now, that you just took the case where k has both 2 and 5. You didn't take the case where it has only 2 or only 5. So, all of these skills together, they are a foolproof way to help you avoid traps that the exam sets for you. And these will keep you very systematic in your solutions. There will be no more guesswork. You will know what you're doing. You will be more sure of your answers. So, click on the link for this. There will be a link coming in for the video lessons that we have on process skills. Just watch these videos. There are example questions on all of these skills. You will see the power of each skill there. Today, my focus was not one skill at a time, right? My focus was an entire topic and an entire approach. But you will see here how every skill individually plays its magic. So, here are the next steps for you. Go through the free trial e-GMAT course. Look at all of the videos that you get there, the practice questions. Again, link to the free trial is going to be in the chat very soon. Prepare for the webinar that you're going to have on Sunday, which is your next quant webinar. There will be some free files you will get on divisibility remainders in the free trial. Prepare, do those free files, and be ready for the webinar, and then really see how everything helps you. You can do practice questions on our quiz platform Scholaranium. You have hundreds of questions from all of those topics, and these are the free questions I'm talking about. Go and experience this for yourself. I really enjoyed being here today. We had a small hiccup, but other than that, it was pretty fun. I hope you let me know how you people enjoyed. These are the webinars I talked about. Links are all in the chat. Do not miss these sessions. This is how, by the way, a personalized plan is going to look like. You're going to see, okay, SC, I'm right now at 83rd percentile. My target is also that much based on the overall score I want. So I don't really need time. I just need to revise. But for arithmetic, I have to go from 52 to a big number. So I need around 2 weeks for that. So this is the level of detail you will get at a subsection level. Thank you for joining me here today. Again, I am looking for some final feedback from all of you. Please put the link to the feedback form, Ashish. We would love to hear from all of you. It'll be like a 1 minute feedback, but it'll mean a lot to us. So if you could just fill that. Yes, the link is now in the chat. I will see you again in another session. Let me just stop sharing. Thank you. Good night. Good day. Bye bye, everyone.